Contour ditch. The contour ditch method is widely used for irrigating close-grown crops on steep slopes. Using this method, ditches are laid out across the slope on a slight grade. Water is released from the ditches by means of siphon tubes or openings in the ditch bank. Plowing a furrow on the lower side of the graded contour ditch so that the soil is thrown against the lower bank is a simple improvement that allows more uniform distribution of flow and generally increases the efficiency of this method. Sprinkle. In sprinkler irrigation, water is sprayed into the air by means of perforated pipes or nozzles operated under pressure. Sprinkle systems can be classified as portable, solid set, or self-propelled. There are many different types of systems within each of these broad classifications. Each type has certain advantages, disadvantages, or application characteristics that may affect its suitability for a particular site. Most sprinkle systems are designed by manufacturer representatives or equipment dealers. It is very important, therefore, that the buyer is aware of the capabilities and limitations of the system under consideration. For the designer to develop an adequate system design that fits the water supply and site conditions, he or she must have such basic information as the water holding capacity and intake characteristics of the soil, consumptive use requirements of the crops to be grown, soil erosion susceptibility, and needed conservation measures. Other information that will be useful to the buyer and designer of a sprinkle system is found in Chapters 3 and 11, Section 15 of NRCS's National Engineering Handbook, and in the Irrigation Guide and in the Field Office Technical Guide. Sub-irrigation. The sub-irrigation method requires special site conditions that permit control of the water table through regulation of water application and drainage. This method is most often used on land that has a high water table and where subsurface drainage is needed to remove groundwater and provide soil aeration. If a high water table is not inherent, a layer of slowly permeable material or some other barrier must exist at a depth that will permit the buildup of an artificial water table without excessive losses. Topography should be relatively flat and uniform. Soils must be deep enough to allow for any needed surface modifications and to permit installation of the planned measures. Soil permeability must allow good vertical and horizontal movement of water. A sub-irrigation system should apply water when irrigation is needed and remove water when drainage is required. Thus, an adequate irrigation water supply and an adequate drainage outlet must be available. The water conveyance and removal facilities may consist of 1. Open ditches with water elevation control structures, 2. Combination open channels and subsurface drains and control structures, or 3. Buried pipelines, subsurface drains, and water control structures. Each site is unique and requires special investigations. System designs must be developed to meet the site conditions. Therefore, these operations should be carried out by personnel who have had considerable experience with this irrigation method. Trickle. Trickle irrigation is the slow application of water on or beneath the surface layer, usually as drops, tiny streams, or miniature spray through emitters or applicators placed along a water delivery line. Trickle irrigation includes a number of methods or concepts such as drip, bubbler, and spray irrigation. Drip irrigation applies water to the surface layer or below in discrete or continuous drops or in tiny streams through small openings. Often the terms drip and trickle irrigation are considered synonymous. Discharge rates for widely spaced individual applicators are generally less than 20 liters per hour, that is, about 5 gallons per hour, and for closely spaced outlets along a tube, or porous tubing, are generally less than 4 liters per hour, or 1 gallon per hour, per foot of lateral or tube. Bubbler irrigation applies water to the surface layer as a small stream or fountain from an opening having a point discharge rate greater than that for drip irrigation, but generally less than 4 liters per minute, that is around 1 gallon per minute. The applicator discharge rate normally exceeds the infiltration rate of the soil, and a small basin is usually required to contain or control the distribution of water. Spray irrigation applies water to the surface layer by a small spray or mist. Air is instrumental in the distribution of water, whereas the soil is responsible in drip and bubbler irrigation. Discharge rates are generally less than 115 liters per hour, that is around 30 gallons per hour. In trickle irrigation, water is dissipated from a pipe distribution network under low pressure in a predetermined pattern. The outlet device that emits water into the soil is called an emitter. In spray irrigation, the outlet devices may be referred to as aerosol emitters, foggers, spitters, misters, or miniature sprinklers. For wide-space permanent crops such as trees and vines, emitters are individually manufactured units that are attached by a barb or other means to a flexible supply line called the emitter lateral, lateral hose, or lateral. For less permanent row crops such as tomatoes, sugar cane, and strawberries, the lateral with emitter outlets is manufactured as a disposable unit, having either perforation spaced every 23 to 92 centimeters, that is, 9 to 36 inches, as in double chamber tubing, or having porous walls from which water oozes. For all types of trickle systems, the laterals are connected to supply lines called the manifolds. With the trickle method, water can be metered to widely spaced trees and vines or to row crops planted on beds. Thus, this method is especially adapted to orchard, vineyard, and vegetable crops. Labor costs and water can be reduced with trickle irrigation because these systems need to be regulated rather than tended, and much of the surface layer is never wetted by irrigation water. Efficient control and placement of fertilizer can be accomplished with trickle systems. These systems can be designed to operate efficiently on almost any topography. The main disadvantages inherent in trickle irrigation systems are their comparatively high cost, susceptibility to clogging, their tendency to build up local salinity, and, where improperly designed, their extremely partial and spotty distribution of soil moisture. Trickle irrigation systems are normally designed and managed to apply light, frequent applications of water and to wet only part of the soil. Therefore, the procedures used to compute water requirements, irrigation depth and frequency, and salinity controls for other methods of irrigation must be adjusted for trickle irrigation. Capacity. Irrigation water must be conveyed from its source through a system of canals, pipelines, or structures to the individual furrow border or sprinkler head. For projects or group systems, a canal system usually delivers the required flow to the farm headgate. The plan must provide conveyance from the headgate or farm source to the individual field and furrow. The conveyance system must have the capacity to deliver to the field a flow that is adequate to meet the largest size of stream required for the irrigation methods planned for the field and to meet the consumptive use of the crops to be grown, making provision for the expected field irrigation efficiency. Some waste results when transporting the water from the headgate or pump to the field. If the water is carried in buried or surface pipelines, this loss may be negligible. In lined ditches, the loss will also be very slight depending upon the type of lining and its condition. Water conveyed in open, unlined ditches may have considerable loss, sometimes 15 to 40% per kilometer, or 25 to 66 2/3% per mile, or more on permeable soils. When unlined ditches are used, the farm requirement is equal to the field requirement plus the amount of ditch losses.